I'm told that the fire will reveal the difference. We started with a sheet of resin. It instantly caught on fire and melted away. Now, let's put a sheet of the newly developed material near the fire. It doesn't catch on fire, it just turns white. Yes, the new material that Kubota developed is fire-resistant. Here's another way to use the new material. The material is converted into liquid form, applied to the surface of a resin and dried. When it is put close to the fire, it doesn't burn. And the flip side remains unchanged. This is a light cover that is being developed for train interiors. The surface is coated with the new material. It may soon be used in bullet trains. It turns out that this new material has another exceptional characteristic. Kubota. In another petri dish is a reagent that reacts to ammonia. When one petri dish is placed over the other, the reagent reacts to the vaporized ammonia and turns purple. A resin sheet and a sheet of the newly developed material are each placed between petri dishes. And after 20 minutes, the one on the left has turned purple. This shows that the ammonia gas had passed through the resin sheet. Meanwhile, the one on the right remains unchanged. It shows that the sheet made with the new material did not allow the ammonia gas to pass through. It is very airtight. Because of this quality, the material is being used as a packaging material for food and medicine. Why is it able to do all that?
Well, that's because it's made out of this.
Is this a stone?
No, it's a type of clay called bentonite.
Clay? The sheet was made out of clay. No wonder it didn't burn when placed close to the fire. A cross-section of the clay-based sheet reveals multiple layers of small tabular crystals that are just 1 nanometer thick. This is what makes it airtight. Kubota began developing this new material in 2009. But development wasn't easy. Because clay is generally weak to water, when made into a sheet and placed in water, it quickly dissolves or falls apart. This is caused by the sodium ion between the tabular crystals. Kubota knew that if the sodium ion could be changed into lithium ion, then it would not dissolve easily in water. However, the time and cost required for the process would not make it profitable. Then Kubota thought up a whole new method. He decided to temporarily replace the sodium ion with a different ion. First, the clay is mixed into a certain liquid. This replaces the sodium ion with a different kind of ion. Then it is mixed with another liquid. This replaces the substitute ion with lithium ion. This method reduced the required work time to just 1/50th and made it possible for them to commercialize the material. The new material is currently being used in hydrogen tanks and electronic substrates. It is said that there are 1,000 ways to use bentonite, and Kubota has its eyes on the possibilities.
Clay has many different functions, and it's a very versatile material. I want to pursue its possibilities and develop new products that meet people's needs.